Hey guys, welcome back to AlgoYogi. We are doing graph series and our next problem in the list is reasons cut by slashes. So let's go to LeetCode. This is one of the trickiest problem, I would say. It's not like something that you see and immediately you have a solution ready. It's something that goes beyond intuition. Well, let's go through it and let's understand how we are going to find the solution. Although the underlying concept behind this problem is really hard to grasp, but at the end of the day, it's just a simple problem. Once you it's like an onion. If you keep peeling the onion, you wouldn't find the onion. You will find just little baddie. I don't know what I'm talking about, but it's a simple problem. What I'm saying, we have to just like unwrap all those layers, and then you'll find just counting the connected components here. All right, so there is an n by n grid is composed of one by one square, where each 1 by 1 square consists of either a forward slash or a backward slash, or there is basically empty string. Now these characters divide their square into contiguous regions. All right, given the grid represented as string array, return the number of regions. All right, note that the backslash characters are escaped, and that's how things that's how computer reads, like it escapes the character after backslash. But so that is why this backslash, we are going to write it by basically double backslash. All right, so let's consider our first example. There it is. So this dot here, just remember this is an empty string. Now, in order to understand this problem really well, let's draw these boxes as like this is zero, this not zero. This dot is an empty square box. This forward slash is also in an empty a square box represented as a shape like forward slash. Then in the next one, this is going to be basically the same structure, forward slash, and then this dot is empty. So now if you see right here, this this shape that we just created, and remember these are kind of like faded. These are like faded, okay? These are not, these ones are not basically considered when you're trying to count the shape, okay? These are not considered. So these are just for basically, these are the borders. The actual line is this. So there are basically two regions in this. So this is one region, this is region 2. All right, so and that's what we need to return. We need to return the number of regions. If you want to take another example, the example 2, so we can understand better what the problem is asking us. So let's take the example 2 is right here. This gives us so forward slash, then backward slash, and then we have basically backward slash, and then forward slash. All right, so let's draw this. So in here, just remember this just represents one backward slash. So this grid is also a grid of 2 by 2. So here we'll draw the grid, and this time right from the beginning I'll draw these borders with the slash. Next, let's draw these backward and forward slashes. So here this first one is a forward slash, next one, this whole together, is a backward slash. All right, then this one is a backward slash, and then this one is a forward slash. All right, so right here in this particular entire grid that we just created, how many shapes do you see? So if you just forget about these these dashed lines, I can see 5 shapes, so, or regions, right? 5 different regions. This is 1, this is 2, this is 3, this is 4, and this is 5. So there are 5 regions in this. So how do we actually come up with a solution that can help us actually count these different regions. Well, as I said, this problem is not something that you read and you're like imagining solution, you're like coming up with, it's not very intuitive. Like if you haven't solved a problem like that, if you don't know the underlying concept, you might have studied the entire graph theory, but like you wouldn't be able to come up with it if you haven't already solved it. So there is a trick to solve this problem. Well, that trick is it's not even a trick. It's just like thinking this problem, outside the box. Rather than working with these slashes, how about you work with zeros and ones, right? So what does that mean? What does working with zeros and ones mean? So this is what I mean. So let's say we have these shapes right here, and I'm going to basically, what I'm going to do is, instead of having this empty string, this dot, what about if I convert it to 0? And then what about I convert this forward slash to 1 and this backward slash to 1? Because these are the boundaries, right? These are the boundaries. These are the boundaries. So what if I do that? Will I be able to count these cut regions? So maybe if I count these number of zeros, then will I have the total number of cut regions or shapes? So let's say if we try that, let's fill our grid, which was basically this. Then if I fill this 0, then 1, then 1 and 0. So if I just count the number of zeros right here, these two, that will just give me, except they're not diagonally connected, that is also giving me 2 regions. But will it work with everything else? Will it work with this? So let's try it. Is it going to work with this problem as well? So we have again this 1 right here, then 1 right here, 1 right here, 1 right here. Well, there are 5 shapes, and here I don't have anything. I don't have like any connected zeros. So what about I convert, instead of using just 1, 0 and 1, how about I actually use, basically I make a 2 by 2 grid instead of just 0. So this is what I mean. And I'm gonna even write a new one. So what if instead of this is not working? We have just realized this does not work. So what about I use 0 0 as 0 0 0 0, 1 as 1 1, so 0 1 1 0, and this one I draw as 1 0 0 1. The reason is so that this 1 represents basically a forward slash, and this backward slash is represented by basically diagonally from left to right, and this one is from left bottom to top right. But let's see if this one is going to work with this shape. So if I draw right here, well, this time it's going to be, if you see, this time it's going to be of shape this way, because you are multiplying each grid into 2v2, right? So here, if I fill this first one is basically forward slash, so I'm gonna fill this 0 1 1 0. Then next one is backward slash, so 1 1 0 0, and then I am going to fill this one. So this is also backward slash. Backward slash is oh sorry, this is not backward slash. This one is backward slash. So backward slash is going to be, and I think I made a mistake in the beginning because I filled this as backward slash. So I'm going to convert that. So I'll just convert this. Yeah. All right. So first one is forward slash. So 0 1 0 1 0. Next one is backward slash. So 1 1 0 0. I think this is a better way of writing. Then next one is backward slash. So first write the ones and then 0. So 0 0 1 1. All right. So let's see these connected ones, the zeros, because that's the one we are looking for. So if you see right here, this one is one connected component. This is 2, so 1 2. This is 3. This is 4, and this is 5. Well, in this case, this works, right? This works. But is it going to work every single time? But let me tell you that this will not, because if I take this next example, let me take this next example right here instead of this. Okay, so I have taken another example right here, and let's see if this approach is going to work with this. So let's convert this grid. Let's convert this grid to how we want it. So it's also going to be a 4x4 grid. All right, so let's fill this. So /0 1 1 0 /0 1 1 0, then /1 1 right here 0, and then last is empty, so 0 0 0 0. Now if you were drawing it like basically this, how many shapes did you see? So this was like here, this was like here, and then this empty. So if you just if we just remove these, how many shapes do we see? Well, I see 3 shapes, don't you? So this is 1, this is 2, and this is 3. So now let's count the number of basically these number of connected zeros together. So this is 1, this is 2 because it's not connected to anything else. This is 1, this is 2. Well, this is kind of connected to all of these. So this is 3, but then this is not connected, and this is not connected, so 4 and 5. But I could only see 3 shapes. That should have been my answer. So that is why, guys, what we will be doing, this 2v2 is not working for us. So what I'll do is I'll basically use 3v3. So what I mean by that is, instead of this grid, we will use 3x3. So what do I mean by that? So what we'll do is I'm just going to remove this. For our approach to work, or maybe, you know what, I'm just gonna copy this and just remove everything here, and then restart. Yes, so for this example, because this is the best example we came so far. All right, so let's draw this. So 0 would be 0 0 0 0 0 0 0 0 0, then / would be 0 0 1 1 1 0 0 0 0, and then backward slash would be 1 1 1 0 0 0 0 0 0. All right, so you can directly see right here that this is /, this is backward slash. If you can see, yes, you can. Awesome, you can see it. All right, so what if we do it like that? Then we will be creating, we will be expanding each of these cell, or the row number, into 3. So this will be of size 6 by 6, right? So let's draw a grid of 6 by 6. So 2 3 and this one and 6. All right, same as here. So 1 2 and 3 and then 4 and then 5 and 6. All right, so just like in this example, if we convert it to this 2v2, and my bad, so sorry, so I had /, I had /, and then empty, and I was having basically 1 2 and 3 shapes. And you will see here after we convert this, so / would be 0 0 1 0 1 1 0 0 0, and then /, so 0 0 1 1 1 0 0 0 0, then here also /, right? So 1 here, then my bad, so 1 here 0 0 0 0, then here it's empty, so all zeros. So now let's count all the connected zeros. Well, this is one group, this is group 2, my bad, these are all connected. So this is group 2. This one is actually the biggest group. This is the biggest group, right? This is the biggest group, and we have one more group. And how did it come up with, why didn't it get connected? Let's see, what mistake did we make? So this, oh yeah, so this 0 we didn't connect this one well. So this one right here, yeah, I mean, so this is first group of zeros, then this one, and this is like horizontally connected, so this is all together with this one, and then this one. This is all coming together. All right, this is all coming together. Awesome. And then this one is all coming, this is the biggest group, this is all coming together. Yeah, do not doubt the approach. This is the best approach. So this is one group of zeros, this is second group of zeros, this one all together, and this is third group of zeros, this one right here. All right, so that's why this will give us our answer 3, and that is why this is the best approach. So this problem will require us to first convert our basically grid into how we want it, and then just collect these number of zeros. All right, so let's write the answer. All right, so let's write our answer, and let me just paste this grid that we are just going to create. So this we will be basically counting the length of the grid, and then with this I'm basically multiplying all the n by 3, because that's the number of rows and columns that we will be having, and that is what we will be filling our grid with. So here we just I multiply each row and each column by 3 so that I can get the next pointer, and right, so and then I am just filling it up all the diagonal positions for backward and forward slashes. And you can see right here that I'm doing it just like switching the the zeros and ones. So for I would say forward slash it's going to be this way, and backward slash it's going to be this way. So this is not super difficult, it's just easy to come up with. But what is more important is counting the collected number of regions. So let's say I'm gonna say num, before that let me just create this for row in range. This time it's going to be this big N. All right, so this big N, and that's also going to be the number of columns. So for C in range, oh my god, I opened a new browser. So this new range, and so these are the number of these are rows and columns. Now what we can do is, if my grid, this is not the grid, we are using this pix new grid, let's call it graph. Let's call it graph. So if this graph, which I should be actually changing it everywhere. Yeah, just do not doubt me guys, why I just copied it, because it's much easy to come up with, and it will only enhance your intuition. I didn't want to do it again. Okay, so this graph, okay, so this graph R and C, if this is equals to zeros, right, and also this is not, yeah, I think we can because we are the one creating this graph, this grid, so we can modify it. We can modify it ourselves. All right, so what I'll do is, if this is the case, then I will increment the number of regions. So I'll call it num regions. Num regions initially 0, then let's increment these by 1. Right, and before you increment, let's call DFS on it, on this row and column, and then finally we can just return this number of regions. So see how this problem actually have this underlying concept of counting the connected components at the end of the day, right? So I will just write DFS, and honestly, yeah, I think this is the best way to write. So DFS will be taking row and column, and as soon as you visit this, let's just mark it visited. So I'll just say this row and column that I just have, I will let's say I'll mark it, I'm going to actually just make it 1 because I can actually modify my graph. So what I'll do is, in my graph, because I'm visiting it, so R and C, instead of visiting, I'll just convert it to 1. Otherwise I am going to visit all the neighbors of this. So what are the neighbors? For let's say dr dc in basically all except diagonally, let's have 1 and 0, then we're gonna have 0 and 1, and then let's have -1 and 0, and then let's have 0 and -1. All right, so in this, let's convert our new row, new row and new column. That is going to be dr plus r dc plus c. And if it's a valid nr, so it's greater than equals to 0, and nc is greater than equals to 0, and nr is basically less than our the range. What is the range? The range is going to be I could have just written the range also, but like the n is the range, right? N is the range. So this is less than this, and nc is also less than this n. So that means we are valid. And also here I can only go forward. I can only call DFS if my graph is actually 0. So graph, my neighbor graph, basically new row and new column is equals to 0, then I can call DFS on it. So I'll call DFS on what? On new row and new column. So NC and NR. Alright, so that would be it, guys. That would be it. And then finally, we don't have to do anything. This does the DFS on all the connected zeros and then comes out. And finally, I hope I'm not missing anything. Well, this is something we can just convert to hide it so that you can see the entire code right here in one go. All right, let's run this. Let's run it and see. New C. Yes, it was not new C. It was NC. Awesome. Awesome. Let's submit. Great. That's a good solution. So let's write down the time complexity. Well, for time complexity, it's going to be 3 into n, right? Or n square, I would say, like this big N square, and this big N is actually equals to 3 into n. 3 into n, this is the small n, and is the number of the length of the grid that was given to us. And for space complexity, guys, we are making this extra space, so this is also going to be n square. All right, that would be it. Let me expand it as well. That would be it. Let's go to AlgoYogi, mark this problem solved. Yeah, I was just rushing it because I'm gonna go play pickleball now. See you guys later in the next problem. Bye bye.